Hello, AS Physics students. Welcome back to the channel. In this video, I am going to discuss Cambridge International AS Physics Paper 2 Structure Questions. The paper that I'm going to discuss is May-June 2025, Paper 22. Are you ready? Let's get started. Now, let us look at the first question first. Number 1A, Table 1.1 lists some physical quantities. Identify with ticks. Which quantities are vectors and which are scalars? Now, what's the difference between vectors and scalar? First thing you need to know, vectors includes not just magnitude, but also directions. Whereas scalars only related to magnitudes. Let us look at the first one, acceleration. Do you still recall the definition of acceleration? Acceleration is being defined as the rate of change of velocity. Since velocity is a vector quantity, therefore acceleration is a vector quantity. Displacement, the definition of displacement is the distance moved in a stated direction. It is actually the shortcut. So that is why displacement is also a vector quantity. Gravitational potential energy. Now, don't be confused by the word gravitational. As long as you see this energy, I will give you a tip here, which is very important tip, save you a lot of your time to memorize. As long as you see the word energy, whether it's a gravitational potential energy, elastic potential energy, or electrical potential energy, right? As long as there's energy included or work, right? This is 100% scalar quantity. Speed is being defined as distance per unit time. Since distance and time are both scalar, speed is a scalar quantity. Temperature is also a scalar quantity. Now, one important tip here, if you have memorized your base quantities, 6 base quantities, you need to know by now that all the base quantities are scalars. B, a constant resultant force acts on a car of mass m. The car moves from rest, from rest, that means initial velocity is equal to 0, with constant acceleration a along horizontal ground. When the car has displacement s, the speed of the car is v. First part, using the concept of work done. Show that the kinetic energy of the car is given by this expression, right? Now, I have to start from the work done. Do you still recall what is the definition of work? Work is being defined as product of force and displacement or distance moved in the direction of force. Now, try to modify this a little bit. If you remember F equal to MA, I try to make my life easier, right? But when I look at the equation of the kinetic energy, there's no A, there's no acceleration. So no worries, all you need to do, scroll up a little bit. Could you see that? These two parts here. Okay, you can actually use one of the kinematics equations because the question did mention that the car is moving with constant acceleration, so you are safe to use these two expressions. I am going to use the second one for sure because there is no time given here. So I'm not going to use the ones that has included the time. I'm going to use v square equals u square plus 2as. Now u is equal to 0 because the car starts from rest, so you put 0 here. Now you need to find your v. Okay, I am going to make a as my subject because there is no a here, so I need to replace the a. Now a is equal to v squared over 2s. Now I sub into this equation 1, okay, into equation 1. Now I have w is equal to m, a is v squared over 2s times s. Now it is time for you to cancel. S and S can be cancelled off, and W is equal to half mv squared. So if you still remember the general definition of energy. Energy is ability to do work. Whenever you have ability to do work, you have energy. So meaning to say that work is equivalent to energy. In this case, because the car is moving, the energy is in terms of kinetic energy. Therefore, kinetic energy is equal to half mv squared. Now, the second part, the mass of the car is 920 kilogram. At time t equals to 0, the car is at rest. At time t equals to 5.8 second, its velocity is 17 meter per second. Calculate the kinetic energy of the car at time t equals to 5.8 second. Now, the second part has something to do with the first part. The first part, we have derive the expression of the kinetic energy, so you're safe to use this expression. Now the mass of the car, you just sub in with 920, and the final velocity you just sub in with 17, you just square it. So your answer should be 1.33 times 10 to the power of 5 joules. 1.33 or 1.3 times 10 to the power of 5 joules. Third part, between time t equals 0 and time t equals to 5.8 seconds, the work done against the resistive forces is 4.7 times 10 to the power of 4 joules. Determine the average output power of the car during this time. Now, when you see the word, okay, another tip that I want to share here is that some of the students, when you read this question, you feel blank. So which expression should I use, right, to get the answer for the output power? Yeah, don't worry about that. You have to know that power is being defined as work or energy per unit time. Now, when there must be a hint given from the question. The hint here is that there's work done against resistive forces. If you see the word work done against resistive forces, straight away just use principle of conservation of energy. Right, so read back the statement given, right? So the question mentioned that there is a force acting on the car. So the force acting on the car, right, will do work on the car, which makes the car moves. Right, so the output, the work done on the car is actually equal to the output of the car. So output on car, okay, output work, this is output energy. Or you can say output energy on the car due to the force, the car has output energy. So I'm going to write in full, output energy on car is, okay, you have to minus, because when the car is moving, there's work done against resistive forces, minus work done against resistive forces equal to the final energy. Final energy of the car is actually the kinetic energy of the car, which is EK. Right, so we have to find the output work or the output energy on the car first. So I'm going to put EO, means output energy of the car, minus 4.7 times 10 to the power of 4 equals to the kinetic energy, the ones that we have calculated earlier, which is 1.33 times 10 to the power of 5 joules. Therefore, the output energy is equal to 1.33 times 10 to the power of 5 plus 4.7 times 10 to the power of 4. Therefore, okay, your answer should be 1.8 times 10 to the power of 5 joules. Now, to get the output power, P out is equal to E out, which is 1.8 times 10 to the power of 5 divided by time taken. The time taken is from 0 to 5.8 seconds, so it is 5.8. Now, okay, your answer should be 3.1 times 10 to the power of 4 watt. So 3.1 times 10 to the power of 4 watt is the answer. And the last part here, at time t equals to 5.8 seconds, the speed of the car becomes constant. State and explain whether the output power of the car is greater than, less than, or same as the output power just before 5.8 seconds. Now, when the speed of the car becomes constant, don't you think that the kinetic energy of the car becomes constant as well? Because the mass of the car is not changing. So I would say that the final energy, or you can put kinetic energy of car is constant. So, okay, so when the speed of the car becomes constant, you have to understand one more thing is that the resultant force acting on car has to be equal to zero, is zero. Therefore, could you see that because this is constant, so the output energy on the car must be equal to the work done against resistive force. Right, because the resultant force is equal to zero. Output force on the car must be equal to the resistive force. Resistive force is actually lesser, which is 4.7 times 10 to the power of 4. Right, so I would say that, okay, because there is no work done to accelerate the car. Speed is constant. Accelerate the car. So the output power of the car is lesser. That's the answer. Now, the next one, question number 2. A, define moment of a force about the pivot. Moment is being defined as product of force and perpendicular distance from pivot. Pivot is actually the turning point. Now, B, a tree of mass 270 kilogram grows out of sloping ground and is supported by a post as shown in Fig 2.1. The ground applies a total force R on the tree at point Q. The center of gravity of the tree is a horizontal distance of 1.2 meter from Q. The post applies a force F of 1,800 Newton perpendicular to the line PQ. The line of action of F passes through point P at an angle theta to the vertical. P is a horizontal distance of 1.6 meter from Q. The tree is in equilibrium and all the forces act on the tree in the same plane. Now, hints given are, first of all, pass through, okay, by taking moment about point Q, you have to show that the theta is 25 degrees, not a problem. Now, this is another hint given. When the question mentioned that the tree or the whole system is in equilibrium, so you have to understand that there are two conditions must be applied here. First one, the resultant force acting on the tree must be equal to zero. Second condition is that the resultant moment on tree must also be equal to zero. That also means that the total anti-clockwise moment on tree must be equal to the total clockwise moment. Anti-clockwise moment must be balanced by the clockwise moment. Right, so I am going to use the principle of moment to solve this. Now, first of all, since the question already given us, this is the pivot. Once I determine the pivot, I can list out, okay? Second step, list out all the forces that are acting on these three. I have F, which is 1,800 acting in this direction. And I also have the weight of the tree. Remember, the weight of the tree must act at the center of gravity of the tree, which is acting downwards here. Weight of the tree is equal to, because the mass of the tree is given, mass times gravitational acceleration. So the mass of the tree given is 220 kilogram, 270, just times 9.81. I am going to use my calculator right here. 270 times 9.81. The answer should be 2.65 times 10 to the power of 3 Newton. So I have two forces. Right, let me highlight the two forces. Now, to use the principle of moment, I need to identify right? Whether the weight of the tree is producing clockwise or anti-clockwise moment, and force is producing clockwise or anti-clockwise moment. Now, look at the weight of the tree first. The weight of the tree is going down, and the pivot is on the left-hand side of the weight. So while going down, it will stick for the pivot, so it will turn in this direction. This is called clockwise moment. Not a problem, right? But the problem is with F. Could you see that the distance between the point of action of F to the pivot is horizontal? Right? Still remember how I define moment? I say force and the distance must be perpendicular to each other. Since the distance is horizontal, I can resolve it. It is already in horizontal plane. The only way to resolve is to resolve the force into the vertical plane. So that vertical force multiplies by perpendicular distance, I can calculate the moment of the force. Now, I am going to draw out this diagram, draw it larger so that you can see. This is the direction of force acting. So let me draw it up. Let me draw it. I am going to draw it right here. Okay, this is the direction of force, which is 1,800. And theta is acting, okay, in the vertical plane. Okay, let me see. Okay, this is theta. So I'm going to draw theta right here. Okay. And okay, this is theta. So this is a force in vertical direction. FV means vertical. Is that okay? Now, could you see that? I can draw my right angle triangle right here. So this is 90 degrees. I need to find, let me keep my ruler first. Okay. I want to find this force. Okay, so I'm going to use the Pythagorean theorem. This force will be adjacent over hypotenuse. F in vertical direction is a hypotenuse. Therefore, it will be cos theta is equal to 1,800 divided by vertical force. Now, vertical force will be acting in this direction. Please bear this in mind. Upwards direction, FV. Now, make FV as the subject. Vertical force will be 1,800 divided by cos theta, which I'm going to use it later. Now, vertical force is acting in upwards direction. Could you see that? While going upwards, it will seek for the pivot. Pivot is on the left-hand side, so it will go out while turning towards the pivot. This is anti-clockwise moment. Vertical force will cause anti-clockwise moment. Now, I'm going to use the principle of moment to solve this. I'm going to write down first anti-clockwise moment equals clockwise moment. So the anti-clockwise moment is the vertical force, which is 1,800 divided by cos theta, that is vertical force, multiplies by perpendicular distance from the pivot, which is 1.6 meter, equals clockwise moment is produced by the weight, which is 2.65 times 10 to the power of 3, multiplies by perpendicular distance between the weight and the pivot, which is 1.2 meter. Now, okay, cos theta as a subject, you should be getting cos theta is equal to 0.9061. Therefore, your theta would be equal to 25.03. It doesn't matter, this is intermediate answer. Then I rounded off my theta to 25 degrees. Now, on Fig 2.2, draw a labeled scale vector triangle to represent the forces acting on the tree. The weight of the tree has been drawn to scale. When the question mentioned that this has been drawn to scale, you have to take out your cm rule to do your measurement. I took out, okay, my cm rule and the length, okay, the whole length of weight you have to measure, and I got 13.4 cm, which is equal to the value of my weight, 2.65. 2.65 times 10 to the power of 3 Newton. Now, I also have the value of the force, which is 1,800. So you do your cross multiplication. So 1,800 Newton has to be 1800 times 13.4 divided by 2.65 times 10 to the power 3. It is about 9.1, right? So I have to, okay, 1800 is about 9.1 cm. So your answer, your value could be slightly different. Just a little bit because there's a range given, so you do not have to worry about that. I'm going to take out my ruler. So all you need to do is to measure 25. Okay. Okay, you have to measure 25 degree from the vertical and you have to draw 9.1 cm. The length is 9.1 cm. So you draw, this is 25 degrees. So I'm going to draw this force, 9.5 cm. Okay, wait, 9.1 cm, sorry, 1, 2, 5, 6, 7, 8, and 9.1. Okay, somewhere here. So then this is 9.1 cm and put an arrow here and use a protractor to measure. This is 25 degrees. You have to use your protractor, no choice, right? And then after that, okay, just draw a close triangle. So this is the resultant force here from that point all the way and then all the way down, okay, here, just like that. And okay, so this is the vector triangle, right? Because the tree is in equilibrium, so that is why it has to form a closed triangle and the direction follow each other. Now, okay, the value that I got here was about 9 point, I got about 6.3 cm here, right here, about 6.1 to 6.3 cm. That should be okay. 6.1 to 6.3 cm. This is how you draw your closed triangle. So you make sure that vector triangle, it has to be a closed triangle because the resultant force acting on the tree is equal to 0. That is why you have to draw arrows of this closed triangle follow each other. Now, the third part, the tree exerts a pressure of 150 kilopascal on the top of the post. Determine the surface area of the tree in contact with the post. I have to write down pressure is defined as force per surface area. Now, I want to find my surface area, which is equal to force over pressure. So the force on the tree is 1,800. The pressure is 150 times 10 to the power of 3. So you should get 0.012 meter square. 0.012 meter square is the answer. Question number 3. Two progressive water waves X and Y travel along a straight line from point A to point B. The variation of displacement of the waves with distance from A at an instant in time is shown in Fig 3.1. State the amplitude of X. Wow, I have stated here. So you see X is a smaller wave, right? The amplitude of X is maximum displacement of the X, which is 10 cm. Now, B, both waves have frequency 16 Hz. Determine the speed of the wave X. I will recall the equation of the wave speed, V equals to F lambda. Now, F is 16. Now, if you want to determine the lambda or the wavelength of the two waves, wave X in this case, right? So you focus on this wave. I'm going to highlight wave X. This is wave X. Let me highlight. This is wave X. So one complete oscillation of wave X, you look at the x-axis, this is distance. One complete oscillation, right? The distance taken for one complete oscillation is called wavelength. So the wavelength of X is 0.4 meter. So 0.4 meter. Or, okay, you could also determine your wavelength from the definition of wavelength. Definition of wavelength is the distance between crest to the neighboring crest. So the first crest is at 0.1 meter. The second crest is at 0.5 meter. So the distance between one crest to the other crest is 0.5 minus 0.1. Still, you get 0.4. Right? So the answer is 6.4 meter per second. 6.4 meter per second. The second part, state and explain whether x and y are coherent. Now, what is the definition of coherent? The definition of the coherent waves is that the waves are having zero phase difference or constant phase difference. In this case, right, x and y, you could see that x and y are not having zero phase difference because, right, they are not in phase. Right, this is wave Y. I'm going to highlight with green color. This is Y. Could you see that? This is wave Y. Okay, this is my wave Y. Right, could you see that the crest of X is meeting the trough of Y? So wave crest is meeting the wave trough. This is called phase difference, out of phase by 180 degrees. So I would say that since the two waves are out of phase constantly by 180 degrees, because each and every time the crest of wave X would meet the trough of wave Y, or the trough of wave X will meet the crest. It is always trough meeting crest or crest meeting trough. So the phase difference is constant, right? So I'll say that yes, they are coherent. Explanation is that both waves have constant phase difference of 180 degrees. They are opposite of each other. Right, now see wave X and wave Y superimposed to form a resultant wave. On fig 3.2, sketch the variation of the displacement of the resultant wave with distance from A at the instant time, shown in fig 3.1. Now, you could see that at time equal to 0, the two waves are of 0 displacement. So you start from 0. At 0.1 meter, you could see that the amplitude of wave X is 10, but the amplitude or the displacement, maximum displacement, because amplitude is a scalar quantity. So I will say that maximum displacement of wave Y is negative 20. So, okay, since displacement is a vector quantity, you want to find the resultant displacement, you just add them up vectorally using a vector. Negative 20 plus 10, you get negative 10. So that is why at 0.1 meter, 1, 2, 3, 4, 5, this is 0.1. So the wave will superimpose and the resultant is at negative 10. At 0.2, you could see that both waves has 0 displacement, so you just put 0 right here. At 0.3, you could see that wave X is at negative 10, but wave Y is 20. So the resultant displacement is 10. 1, 2, 3, 4, 5. This is 0.3. I just put 0.1, 0.3, 0.5, easier. So 1, 2, 3, 4, 5. This is 0.7. 0.9. So at 0.3, the resultant is 10. At 0.4, you could see that both waves are at 0 displacement, so you put 0 here. At 0.5, you could see that wave X is 10, but wave Y is negative 20. That is why they will meet the resultant displacement is negative 10, and at 0.6 is 0. You could see that at 0.6 is 0, 0.8 is also 0, so I mark 0 first. And 1 is also equal to 0, so I mark the 0 point first. At 0.7, let me see, 0.7 is at the middle between 0.6 and 0.8. Y is at 20. X is negative 10. So the resultant would be here. I believe you know the pattern right now, right? And then 0.9 at 0.9, y is at negative 20, but x is 10, so that is why this is 10. Negative 10, right here. Okay, somewhere here. Now I'm going to use different color to draw, right? So you can see that this is the wave. Okay, please forgive me. Okay, my wave might be a bit ugly. I hope you don't mind, but something like this. Okay, something like this. Okay, so this is the wave, resultant wave. Now let me erase this part a little bit. Right, this is the one. Now, part D, the intensity of wave X is Ix, the intensity of wave Y is Iy. Use fig 3.1 to determine the ratio of Ix to Iy. Now, first of all, you need to understand that intensity is directly proportional to amplitude squared. By the way, amplitude is a scalar quantity. Right now, okay, to get rid of this proportionality, I'm going to put I equal to Ka squared. K is a constant. So Ix is equal to K, where is the amplitude of X? The amplitude of X is 10 cm. Don't bother about the 10 cm, just put 10. 10, you just square it. So Ix is equal to K 100. Iy, on the other hand, is equal to K times amplitude of Y is 20. So you just put 20 square. Iy is equal to K times 400. Ix over Iy is equal to K 100 divided by K 400. K and K you can just cancel off. That is why you will get 0.25. So 0.25 is the ratio. And I want you to bear this in mind. In physics, we do not allow answer in fraction. You cannot place your answer. You cannot write your answer in terms of fraction. That is not being allowed, right? Because we want to see the number of significant figures that you put. Even though it is ratio, you still have to put it in terms of 2 to 3 significant figures. Now, question number 4. A small ball is dropped from rest from height h1 above the ground and falls vertically downwards. The ball collides with the ground and bounces back vertically upwards, reaching a maximum height, h2. Fig 4.1 shows the ball just before and just after hitting the ground. The ball has a mass of 0.25 kilogram and is in contact with the ground for a time of 0.818 second. Just before the ball hits the ground, it has a speed of 5.2 meter per second. Just after it leaves the ground, it has a speed of 3.6 meter per second. Air resistance acting on the ball is negligible. A, state and explain whether the collision is elastic or inelastic. Now, easier way. You don't have to do your calculation because this is just 1 mark. It's not worth, right? So this is what I call initial before hitting the ground, going towards the ground. That is being called initial speed. And you look at final speed. Do you think that the initial speed is equal to final speed? 5.2 and 3.6. It is clearly different, right? So when the two speeds are different, initial and the final speeds are different, it will cause the kinetic energy to be different. So one of the characteristics of the elastic collision is that the total kinetic energy must be constant. Or in other words, the kinetic energy before the collision must be equal to the kinetic energy after the collision. Since the speeds are different, kinetic energies are definitely different. So I'm going to say that the collision is inelastic, right? Inelastic. Due to different speeds, okay, or you can say initial speed is equal to 5.2 meter per second and final speed equals to 3.6 meter per second, right? Total initial kinetic energy is not equal to the total final kinetic energy. Now, B part 1, calculate the change in momentum of the ball during the collision with the ground. So the change in momentum is mv minus mu. M I factorize because this is just the mass of the ball, v minus u. You have to bear this in mind. Momentum is a vector quantity. Now, direction counts. This is one of the tricky questions. Could you see that initial velocity is downwards? The direction of the initial velocity is downwards, but the direction of the final velocity is upwards, right? Up and down are opposite directions. So you have to put positive to one direction and negative to the opposite direction. To make my life easier, I'm going to put positive to the final velocity and negative direction to the initial velocity. So the final velocity, mass of the ball, let me see, the mass of the ball is 0.25 kilogram. So I'm going to write down 0.25. Final velocity of the ball is 3.6 minus initial velocity of the ball is negative 5.2. Now work it out. The change in momentum of the ball should be 2.2 kilogram meter per second. So 2.2 kilogram meter per second is the answer. Determine, now part 2, determine the average force on the ball during the collision with the ground. Average force is being defined as the change in momentum per time taken. Since you have calculated the change in momentum, save your time. 2.2 divided by time taken is 0.18 second. Just put 0.18 second and the answer should be 12.2 Newton. So 12.2 Newton is the answer. And part C, calculate the ratio of H2 to H1. Now, the ratio thingy, okay, you just read back the question. I want you to see this. Hint is actually being given. This is the hint. Air resistance acting on the ball is negligible. I am going to use the principle of conservation of energy. Now, the ball is dropped from rest, right? So I'm going to do H1 first. This is the ball initial. Okay, initial or before the ball is dropped from a certain height, the height is called H1. So since the ball is at rest, the ball has gravitational potential energy. When the ball is moving downwards, the gravitational potential energy is being converted to the kinetic energy of the ball. Now I'm going to use principle of conservation of energy. Gravitational potential energy is converted to the kinetic energy. mgh is the expression of the gravitational potential energy. Kinetic energy is half mv squared. Now m and m, you can just cancel off. 9.81 times h1 is equal to half v squared. Initial velocity is 5.2, you just square it. Therefore, your h1 is equal to 1.38 meter. And after that, the ball rebounds. Remember, the ball rebounds to a certain height, which is h2. But the speed of the ball is 3.6, right? Now, since the ball is moving, the ball has kinetic energy, which is being converted to gravitational potential energy. Now, I'm going to use principle of conservation of energy. GPE, half mv squared. This is mu squared, actually. I'm supposed to put it as mu squared. Initial, we just put it as u. Equal to mgh2. Just cancel. Half 3.6 squared is equal to 9.81 H2. Now H2 is equal to 0.661 meter. So the ratio of H2 to H1 is 0.661 meter divided by 1.38 meter. So the answer is 0.48 without the unit, because meter and meter can be cancelled off. Now, question number 5, define the modulus that is very young. Yeah, young modulus is being defined as ratio of stress to strain, right? That's all. B, a wire of unstretched length, which is original length, 0.81 meter, is made of a metal with Young modulus given. Young modulus, this is a symbol that I use for Young modulus. Of course, you can use different symbols. It's up to you. So this is original length. The wire obeys Hooke's law and has a constant cross-sectional area. Fig 5.1 shows the force extension graph for the wire. Now, first one, determine the cross-sectional area of the wire, and they give you 3 marks, right? Since the Young modulus has been given, so I'm going to define Young modulus, which is stress over strain. Stress is being defined as force over cross-sectional area, whereas strain is being defined as extension over original length. Now, Young modulus is equal to FL over AX. Right, since figure 5.1 is being given, I want you to see this. This is force against extension. Since the graph is started from origin, the graph starts from origin, that is why I could also use gradient of the graph. Gradient of the graph is equal to the ratio of the graph because the graph starts from origin. Now I just put F over X as a gradient, because this is Fx graph, times length, original length over cross-sectional area is equal to Young modulus. Therefore, okay, Young modulus is being given, so you don't have to worry. Young modulus is given is 95 gigapascal. 95, I'm going to start in here. Giga is 10 to the power of 9, right? Okay, gradient of the graph. Now I want to determine the gradient of the graph. I'm going to use the 2 points. First one is 0, 0. Second one, I might want to use this one. Okay, something 500. Let me see what is the value right here. Okay. Oh, exactly 4. And beware, some of students might make careless mistake here. Look at the power. You have to include the power. So the extension is 4 times 10 to the power negative 3, right? So the gradient of the graph is 500 minus 0 divided by 4 times 10 to the power negative 3 minus 0 times the length. The length is 0.81 over cross-sectional area. Now make cross-sectional area as the subject. You should get 1.07 times 10 to the power of negative 6 meters squared, or 1.1. 1.07 times 10 to the power negative 6 meters squared. That's the answer. Now, the second part, the extension of the wire is initially 2 times 10 to the power negative 3, the extension, initial extension. Determine the work done to increase the extension of the wire to 3 times 10 to the power of negative 3. Now, I need to use my ruler again. Where's my ruler? Okay. Initial extension is, wait, let me do it first. Okay, initial extension is 2. I'm going to use different colors so that you can see this is for different parts. Initial extension is 2. Final extension is 3. This is the one. Okay, keep the ruler. And okay, I look at the value first on the y-axis. And this is the value on the x-axis. This is 3938,370 Newton. This is 1234. This is 250. Right. When a graph is being given and they ask you to find the work done is actually equal to area under the graph. Right? Work done is equal to area under graph. Remember. So, okay, it is the area of this part. Right, now this is the area of trapezium. Can you see the shape? I'm going to highlight it for you so that you can see it. This is actually trapezium. Right, so I'm going to find the area of trapezium. So you need to use a little bit of math here. So half times a plus b times the height, right? So half is equal to half. A is 250, B is 370 times the height, right? Or the distance here, the height here. So this 3 minus 2 times 10 to the power negative 3 is 1 times 10 to the power negative 3. 1 times 10 to the power negative 3. So you should get 0.31 joules. 0.31 joules is the answer. Number 6. A. Define electric potential difference across a component. Electric potential difference is being defined as work done per unit charge in bringing the charge from one point to another. That's the definition of electric potential difference. B, a circuit contains 4 resistors and a battery of EMF 8 volt with negligible internal resistance. When the variable resistor has resistance R, the currents in the circuit are 0.03 ampere, I1 and I2 as shown in fig 6.1. Now determine the charge passing through the battery in a time of 4 minutes. Still remember the definition of charge? Product of current and time. Calculate! Now the current coming out from the battery is 0.03 and the time is 4, but you look at the unit of the charge. It has to be measured in coulomb. Therefore, your 4 minutes must be changed to second. So you will get 7.2 coulomb. 7.2 coulomb is the answer. Calculate I1. Could you see that I1 is the current that flows through both 430 ohm and 240 ohm, right? 430 ohm and 230 ohm are connected in series. That is why I'm going to use Ohm's law to solve this. V equals IR. The total V across 430 ohm and 240 ohm is actually the EMF of the battery. I across the two resistors would be the same, which is I1, and this is the total resistance of the two resistor. Now, I1 supposed to be 0.012 ampere. 0.012 ampere is the answer. Now, the third part, calculate I2, right? So to calculate I2, I am going to use the Kirchhoff's first law. Could you see that this is a junction? Still remember the statement from Kirchhoff's first law? States that at a given junction, the total current into the junction must be equal to the total current out from the junction. The current into the junction is 0.03 ampere. Current out from the junction are I1 and I2. So I'm going to write down 0.03 is equal to I1 plus I2. 0.03 is equal to I1 was the current that we have calculated in part 2, 0.012 plus I2. I2 would be 0.03 minus 0.012. So you will get 0.018. Now 0.018 ampere is the value of I2. And the last one, determine the value of R. So determine the value of R. I'm going to look at only I2. I'm going to use Ohm's law, V equal to IR. Right, still remember if 210 and R are connected in series, so I'm going to use the EMF of the battery. This is I2 that flows through 210 and R, I2. So you just take I2 value, which is 0.018, and the total R would be 210 plus R. So you make R as the subject. R should be equal to 230 or 234 ohm. 234 ohm. Now, C, variable resistor in B is fitted with a scale so that its resistance can be accurately determined. Resistor of resistance 240 ohm is now replaced by a new resistor X of unknown resistance. A galvanometer is connected as shown in fig 6.2. With reference to the ratios of resistances, explain how this circuit can be used to determine the resistance of X. Could you see? This is resistance of X. Now, before that, I want you to see this. This is a galvanometer. This galvanometer shows 0 reading. It also means that the potential at 210, or I put A, potential at point A and B are the same. Okay, another thing that I would like to tell you is that whenever you see a battery of 8 volt here, bear this in mind. The potential coming out from a positive terminal of the battery is 8 volt, and the potential going back to the negative terminal of the battery is 0 volt. So the potential difference, or the EMF across the battery, is 8 minus 0, which is 8 volt. Right? So this is 0 volt, this is 0 volt. So it is not important here. Right? Now, okay, first thing, when this, we need to find the potential difference between point A and 0 first. Point A, potential difference, okay, across the variable resistor. Right? They call it as variable resistor. So we have to find the potential difference across the variable resistor first. Then when we have the potential difference across the variable resistor, which is A to 0, AO, I call it, must be equal to the potential difference between X, across X, right? So once you get that, just use the potential divider concept. Do you remember potential divider? V across X over the total, V input. V across X is equal to the total V, which has already been given, which is 8 volt. The total V has to be 8 volt, equals to R across X over total R. Total R is 430 plus X. Right? So you can determine Rx, sorry, this is Rx, sorry. Okay. This one has to be, let me erase this. This one has to be Rx. Since Vx is already been determined, right? The Vx is equal to V across the variable resistor. So I'm going to write down. Okay, galvanometer showed 0 reading, indicating potential difference. If you want to use the symbol short form of PD, you just write down the full word first and then you put a bracket PD. Across variable resistor, or I write AO, right, is the same as, okay, since I already explained PD, so I just use PD across X or BO. Now, by calculating PD across variable resistor, PD across X can be determined. So resistance, okay, using potential divider ratio. Okay, I'm going to write down, yeah, using potential divider ratio, V across X over 8 is equal to R across 8 over 430 plus R across X, okay? Rx can be calculated. Done. Now, number 7, A, state what is meant by fundamental particle. Fundamental particle is the basic of all the particles. Fundamental means basic, right? So it is the simplest particle which, sorry, which cannot be divided into smaller particle. That's it. Full stop. B, a nucleus X has 14 nucleons and P protons. The ratio of charge to mass for nucleus X is 4.1 times 10 to the power 7 coulomb per kilogram. Determine P protons, right? Now I write down the nuclide notation for X first. This is nucleon number, represents the mass of that nucleus, and P proton, right? And then the question gives you the ratio of charge, that means the proton number divided by nucleon number. Nucleon must be put in U. U is called unified atomic mass. Right, but I have to look at this point here. You see, this is coulomb per kilogram. Right, so I have to change this U to kilogram. Right, how to change that U to kilogram? Let me write this down first. Okay, you scroll up to the second page. Right, scroll up all the way to the second page. Okay, go up to the second page. You could see that. Okay, now could you see that the data unified atomic mass unit 1U is equal to 1.66 times 10 to the power of negative 27 kilogram. So you use that to convert the U to kilogram. So I'm going to use that exactly the same. Right, this is it. Okay, so proton divided by 14 times 1.66 times 10 to the power of negative 27 is equal to 4.1 times 10 to the power 7, right? So P is equal to 9.53 times 10 to the power of negative 19. But I want it in terms of coulomb. So you have to divide by 9.53 times 10 to the power negative 19 divided by, okay, I need to scroll up. So all you need to do is turn to the data, right? On your question paper itself. So I scroll up to show you. This is the elementary charge. So you have to divide by the elementary charge, which is 1.6 times 10 to the power negative 19 coulomb, right? So I'm going to divide that. Oh, okay. Here, 1.6 times 10 to the power negative 19. So you get about 5.96. But bear in mind, this is proton number. So we have to round it off to the whole number, which is 6. So the proton number is 6. Now, the second part, nucleus X undergoes beta negative decay to form nucleus Z. Complete the equation representing this decay, right? X, you have already calculated the proton number, which is 6, right? Undergoing beta negative, so 0, negative 1, beta negative. So you balance the nucleon number, 14 is equal to 14 plus 0, and balance the nucleon number, 6 is equal to 7 minus 1. And what about the other one? The other one could be anti-neutrino. That's the energy. C, a sample of radioactive substance emits particles that are positively charged and have a continuous range of kinetic energies. This is a keyword, continuous range of kinetic energies. State and explain whether the nuclei in the sample are undergoing alpha decay, beta plus decay, or beta negative decay. I would say that since a continuous range of kinetic energies are given, so this is definitely beta decay. Right? So in this case, it has to be beta plus decay. You know why? Because particles are positively charged. So I would say beta plus decay. Only beta decay has continuous range of kinetic energies. Because after all, beta can be divided into positron, which is positive, beta plus, and electrons. They are all moving with different speeds. Right? Okay. And then I would say, okay, only beta decay have range of kinetic energies. Okay, and then due to different speeds of positrons and electrons. Positrons are beta negative. Since particles are positively charged, nuclei, okay, are undergoing beta plus decay. So that is the end of our discussion for this paper. So if you have any doubts, do not hesitate. Just comment below. And if you need a totally free PDF of this paper, all you need to do is just to comment PDF and I will send it to you. Thank you very much for watching and I will see you in my next video. Bye.